Dear students, already we have started the module number 4, bipolar junction transistors, feedback amplifiers and oscillators. Already you are completed in the last session bipolar junction transistors. The next of this module is feedback amplifiers. In this you are going to discuss properties and advantages of negative feedback, types of feedback, voltage series feedback. In this you have to find the gain stability with feedback, that is voltage series feedback. In this you are going to discuss one by one. First we have to what is the feedback. The feedback is the very important aspects in that amplifier signal. The process by which some part of a fraction of output is combined with the input is known as feedback. Means any process for the feedback amplifier, that is feedback to the input and combined with the input signal, that is known as feedback amplifier. And feedback amplifier are the types of amplifiers in which part of the output is given back to the input. Any output of the signal is given back to the input, that is feedback, that is output to the input. An amplifier is device that amplifies signal. An amplifier is very important used to in the electronic signal to amplify the signal to higher the input. The process of injecting a fraction of output energy of some device back to the input is known as feedback. It has been found feedback is very useful in reducing noise and making the amplifier operation stable. And in this amplifier signal, to any type of noise is occurred in the electronic circuit, it is very important use for the reducing the noise. And in the feedback amplifier there are two types. One is the positive feedback amplifier, the second one is the negative feedback amplifier. In this positive feedback amplifier, using the source signal and feedback signal are in the same phase. Any type of input source signal you are given and feedback are both source output voltage and feedback output voltage are in the same phase, no change. Vs is equal to Vf, no change of the signal. On that amplifier in which source signal and the feedback signal are in the same phase, the feedback signal is applied increase the strength of the input signal. The second one is negative feedback amplifier. In this type of amplifier, source signal and the feedback signal are the out of phase. Any type of source voltage, feedback voltage are the out of phase. What is the difference of positive feedback amplifier and negative feedback amplifier? The positive feedback amplifier, the for both source signal and feedback signal is same phase, no change as it is. The next here negative feedback amplifier, source signal and feedback signal are out of phase. In this module you are going to discuss negative feedback amplifier. The properties of negative feedback. There are different type of properties of negative feedback amplifier. What are the first property? The negative feedback increase the input impedance, output impedance of the output voltage amplifier, and the transfer gain of the amplifier. Negative feedback increases the frequency response. Negative feedback increases the linear large range of operation. Negative feedback causes reduction noise. Phase distortion is reduced. The next is important. What are the advantages using negative feedback amplifier? There are various advantages here. The negative feedback has less frequency distortion. It has highly stability gain. It can control step response of amplifier. It has less harmonic distortion, amplitude distortion, phase distortion. It is controlling the very less signal. And the negative feedback reduces the noise. Input output impedance can be modified as desired. It can increase or decrease the output impedance. It has higher fidelity, that is more linear operation. The next is disadvantages of negative feedback amplifier. It is a reduction in gain. It increases the output resistance in case of current shunt and current series feedback amplifier. There are two ways to discussing. One is a current series and current shunt. Shunt is nothing but here is the parallel of the amplifier. See here you are going to discuss of the what is the feedback. Here is the input voltage given and load is feedback to the and where beta is the feedback factor. And see what is the feedback amplifier. The output is fed back to the input. This is the feedback amplifier. This is the basic circuit of feedback. The any output is given here, that is fed back to the input. And next is negative feedback amplifier. Yeah, this is feedback network. This is feedback network and feedback signal is goes to the input signal to the output signal. Next, The types of negative feedback. There are various types of negative feedback. Actually, there are four types. There are four types of different kind of negative feedback amplifier. The first one is voltage series feedback, voltage shunt feedback, current series feedback, and a current shunt feedback. Here, we are going to discuss only one, that is voltage series feedback. Here, voltage series feedback. Here, this is the basic circuit diagram of voltage series feedback. This is the two blocks you are used here. One is the amplifier with gain A, feedback circuit beta, where beta is the feedback factor. And in this amplifier with gain, given the input supply voltage Vs, and again goes to the feedback circuit, that is feedback voltage. That is feedback voltage is equal to beta into V naught, where beta is the feedback factor and V naught is the output voltage. This feedback factor is connected to the V naught. Vi is the input voltage, V naught is the output voltage with respect to the load resistor RL. In this voltage series feedback, you can calculate the gain. What is the gain stability? You have to already know what is the gain. The gain is defined as the ratio of output voltage to the input voltage. Here gain stability how to calculate. In this feedback, that is V naught, output voltage fed back to the input. First you take the output voltage plus amplifier with gain A into beta into V naught. That is V naught is equal to Vf. That is V naught plus A into beta V naught. That is output voltage V naught is equal to this gain A into beta into V naught. That is V naught plus V naught. That is equal to Z naught into I naught. The V naught will be making outside 1 plus A into beta. That is equal to Z naught into I naught. Therefore, this V naught by I naught is equal to Z naught divided by 1 plus A into beta. Therefore, ZOF, that is a impedance of this is equal to Z naught divided by 1 plus A into beta. Here, the output voltage impedance is reduced by factor 1 plus A into beta. This is the voltage series feedback. And this circuit diagram and this equation are very, very important of the voltage series feedback. The next for here, what is the input feedback network is in the parallel with the output of the amplifier. A fraction of the output voltage through the feedback network is applied in series with the input voltage of the amplifier. The shunt connection means the parallel connection at the output reduces the output resistance, or the series connection at the input increases the input resistance. These are we are going to discuss of the feedback amplifier.